In this video, we're going to be talking about several problems related to a review assignment we're going to do in class. So we're just going to spend a few moments doing a warm-up just to make sure everybody's in the right place coming out of a weekend. So here we go. Go ahead and try these on your own. The first up, we have some warm-ups. If you travel 4 hours at 65 miles per hour, how far did you go? So again, at this point, I'm pretty sure we're familiar with our distance equals rate times time relationship. And if I take a look at this and fill in what I know, it's asking for the distance. So I don't know my distance. It gives me a rate of 65 miles per hour. And I'm going to multiply that by time, which is 4 hours. I'm writing it out using units, so I can just make sure that my units all are correct, and hours cancels with hours. And my only units left are miles. So that gives me distance equals 4 times 5 is 0, carry the 2, 24, 25, 26, 260 miles. All right, so that's your distance equals rate times time relationship. Sometimes you might have different information, but we're still relating distance, rate, and time. Here you'll notice we have information about time. We have information about the distance, but I don't know how fast I was traveling, so I don't know what the rate is. So I'm still going to set up my same equation. My distance equals rate times time. I'm going to plug in what I know. I know 490. I don't know my rate. I do know time. I'm going to put my variable backwards, so I'm going to do time times rate. So I'm going to do 7 times my unknown r. And then hopefully it's very obvious to get r, we would just divide by 7. And so let me grab my calculator real quick. And I'm going to do 490 divided by 7. And I get, oh, I wasn't even paying attention. That was silly. I get a rate of 70. Now, you'll notice this time I didn't use units. And so I'm not really happy with that. So what I probably should do is go back and think about how the units are involved. So let's go ahead and do that. So I'm going to redo this setup. I have 490 miles equals an unknown rate times 7 hours. So what I really should show is that I'm dividing by 7 hours. And the 7s and the hours cancel out. And I divide by 7 hours. And I get a rate, and you'll notice that my units don't cancel out. So I'm left with an answer of miles per hour. So the answer is 70 miles per hour. All right, we go to part C. All right, this time we're doing a little bit something a little bit different. I want you to think about how you would go about finding out if today, let's say, is your 15th birthday, how many seconds have you been alive? We won't worry about leap years, and then we won't worry necessarily about what time of day you were born. Let's just say it was the second you start calculating it. So, what we want to do here, again, I'd prefer that you pause the video and think about this on your own. But for me, there's a lot going on here. I got to think about years, and then I guess days, and then months, or probably not months, but then I got to do days and hours, and then I got minutes, and I got to go all the way down to seconds. So that's a lot to keep track of. So being organized on this problem, I think, is really going to help. So I'm going to start with my known information, and that is that I've been alive for 15 years. And then I'm going to do some math to 15 years. And after I'm done doing all that math, I want an answer, and that answer needs to be in seconds. And so what's going to help me get there is using unit analysis. So what I'm going to do is go step by step and figure out how can I cancel out years and give it to some other known consistent information. So I know that in 1 year, and I want years to cancel, so this fraction I'm about to write, I'm going to write year in the bottom. And I know a number of days in a year. And we're going to forget leap years, so we're just going to be consistent. So there are 365 days in 1 year. All right. Now I'm going to go from days. I'm going to step down from that into something I know, trying to get closer to seconds. And I know that in 1 day, there are 24 hours. So I need day at the bottom and hour on the top. So in 1 day, there are 24 hours. And then I'm going to go from hours to minutes. So I know in 1 hour, there are 60 minutes. And then I'm going to go from minutes. So I want minutes to cancel, so they go in the bottom, and seconds. And I know that in 1 minute, there are 60 seconds. So there would be kids who would come up to me on a question like this or something like this, where they say, do I multiply or do I divide by 60? Or do I multiply or divide by 24? Well, honestly, if you ask me that question without a setup, I don't know. And I'm not going to even try to know, because I don't need to worry about that. Because by setting up the units the way I have, now I know exactly what I need to do. Minutes cancels with minutes, hours with hours, days with days, year with year. And my only unit left in the problem now is seconds. So now I'm just going to do the math that I see in front of me. And then what I see is a bunch of fractions being multiplied together. And in the denominator, I just have 1. So I'm going to multiply all the way across, and I'm just going to get 1 in the bottom. And then on top, I just need to multiply all the numbers together. And so this way, I don't even have to keep track. I don't have to try to remember where I'm at. I just do the math in front of me. And that is what having a math thinking brain will do for you. It'll give you confidence in the long run that you haven't missed something, right? So I'm talking while I do this. So I'm going to double check I do my math wrong. Right. 15, 365, 24, 60, 60. All right. Enter. All right. The answer is, what is this? 473 0 4 0 0 0 0. 1, 2, 3, 4 zeros. Yes. So comma, comma. So the answer is, we've been alive if on your 15th birthday, exactly 15 years after you were born, to the second, minus leap years, looks like about 473 million seconds. Okay. So the purpose of this is, again, just to demonstrate to you how units can help you answer a question that you may not be sure what you should do. The units will tell you what to do. All right, part D, now we just got a basic equation here I want to solve, but I've thrown in some fractions. But that doesn't change the overall method. There are things we could do to make this maybe easier, and I can show that a different way. But let's just attack this as if it's a normal problem, and that would be, let's get our x's on the same side together. So I am going to subtract 1/15 x from this side, and I'm going to subtract 1/15 x on this side. Okay. At the same time, I want my numbers to go to the other side. So if I move the variables to the left, I want my constants without variables to go to the other side. So I'm at the same time going to add 1/5, because that'll cancel out the 1/5. I'm going to add 1/5. And I didn't give myself a lot of room, so let's see what we have left. I have 1/3 x, and I'm just going to write it like this, minus 1/15 x equals, because that canceled and that canceled. And then I've got 2/5 plus 1/5. Now I can just, those are common denominators, I can just add those together. All right, to add the numbers, or I guess subtract the numbers on the left side, we need a common denominator. So the common denominator, I can turn a 3 into a 15 pretty easily by multiplying it by a 5. And so to keep it balanced, I'm going to multiply by 5 over 5, because that's the number 1. It doesn't change the number. So I'm going to turn this into 5/15 x minus 1/15 x equals 3/5. And now I can combine those. 5 minus 1 is 4/15 x equals 3/5. Next up, I need to get rid of that 4/15, and I'm really hoping we're all on the same page at this point. I'm going to accomplish that very easily by multiplying by 15/4. 15s cancel, 4s cancel, and I'm left with x equals, over here, I can do some reducing. I can multiply first, but for me it's easier to recognize that within 15, I've got a 5 times a 3, right? So let's scratch that out and call it 5 times 3. And then this 5 in the denominator can cancel out that 5 in the numerator. Nothing else cancels, and so I get an answer of 9/4. All right. There are additional ways you could tackle this problem, but I'm going to leave it right here for now because I really want you to practice the fractions. All right, let's move on. Today, we're going to also practice a few story problems because I know the first go around did not go very well. So it'd be easy for me just to say, oh, let's not worry about them. But this is something we need to get good at. So here we go. Several friends jumped in a car and drove to the beach. The drive there took 4 hours. So I'm making note that I've got a time. The drive home took 6 hours. So I've got another time. The average speed on the way there was 20 miles per hour faster than their speed on the way back. Okay, so they're talking about rates here. How fast were they traveling on their way home? So that nice part right here, this question is usually what we're going to let be the variable. So this is a scenario like we'd had on the last one where we're going to drive in our car and we get there, and then later we're going to drive in our car and come back. And so we have a distance equals a rate times a time, and I have a distance equals a rate times a time. And what do we know? We know the two distances are the same, even though the rates and times are different. So we're going to write an equation for what we know. So I'm going to rewrite the top equation. I don't know the distance. Several friends jumped in the car. The drive there took 4 hours. So I know I've got a 4 times, and I wrote the number first. I know it's in the back of this equation, but we can multiply in any order. 4 times the rate. I do not know the rate, so I'm just going to kind of leave that blank for a minute. And then I'm going to come down and look at the other one, and I have a distance equals, this one took 6 hours, and I don't know the rate. But if you remember the question, how fast were they traveling? So that's the one I want to know. I want to know what this is, so let's call this R. So when I solve for R, I'll have my answer. So distance equals 6 times R. Let's go back up here, and we see that their rate was 20 miles per hour faster on the way there. So if my rate on the way home was R, then my rate on the way there was 20 more than that. And now I've got two equations. And since the distances I'm traveling are the same, I can just put them together. And I know that distance 1 is the same as distance 2. So that's going to leave me just with 6R equals 4 times R plus 20. Distance equals rate and time, and equals rate and time. So now I've got 6R equals 4R plus 80. I'm not going to divide by 4. That was silly. I am going to subtract R. So we get 2R equals 80. And I divide by 2. And I get that my rate is equal to 40. So let's answer the question. How fast were they traveling? They traveled 40 miles per hour. So then that means they did 60 miles per hour on the way there. All right, part B. Jay goes to the store and bought a pair of pants, and the price was $74.99. If the sales tax is 7.8%, what's the total cost of the pants? All right, so when you go and buy something, just in case we haven't bought anything in a while, or if someone else takes care of that for you, I know that the total price is going to equal, well, let's do this. I'm going to call that T. So I'm going to let T equal the total price. So I'm going to say that off to the side. T equals total cost. I'm going to let P equal price of the item. And let's see where we get with this. So if I go to the store, my total cost is going to equal, well, $74.99 at least. So I'm going to pay $74.99, but I'm also going to add some to that. So I'm going to add whatever 7.8% of that price is. And so I'm going to do plus $74.99. And if I want to find 7.8% of something, I multiply it by 0.078. 7.8%. You remember the word per just means divided by, and cent is the prefix for 100. So when you see 7.8%, it's really telling you 7.8 per every 100. And so that's 7.8 divided by 100. And when you divide by 100, that's going to move the decimal over 2 places, and you get 0.078. So 7.8% just means that. So I'm going to grab my calculator, and it looks like all of my math is on one side and my variable's all by itself. So I'm going to do 74.99 times 0.078. And so that's going to give me $74.99 plus, I'm going to round to the right number of dollars here and right number of cents, $5.85. So now I'm going to add those together. And I get that my total price is approximately, because I rounded, $80.84. All right. So if I was going to say what I did here as an equation, then what I did was I set this up and I said my total price is equal to the price of the item plus the price of the item times the tax rate, making sure that we're using the decimal equivalent of that rate. All right, so that leads us to our last example of the day. Later, Jay went to another store and spent $50.13 on a nice shirt. If that was the total price with tax included, how much did should be a T right there, how much did just the shirt cost? So we're going to take this equation we just wrote. My total price equals the item cost plus the item cost times the tax rate. Now we're going to solve for what we don't know. So here we go. I'm going to write it down. T equals P plus P times R. And I know the 50. I don't know the price. I don't know the price, but I do know the rate of 0.078. So written another way, I have P plus 0.078P. So if I add those together, I get $50.13 equals 1P plus that would be 1.078P. So now if I want to know the price of the item, some simple algebra will help us get the answer. So I just take 50.13 and divide it by 1.078, which looks like I get a price of approximately $46.50. Now let's kind of make sure that makes sense. We wouldn't expect a huge tax bill for $46, and I ended up paying $50, about $5 in tax, $4. That seems pretty reasonable, and so I feel pretty good about that answer. All right, so in today's little mixed review assignment, we're just going to practice solving some equations and then we're going to do some story problems. I think I've given you enough of a review on these story problems that you should be able to set them up and make some good progress. Work hard in class, maybe start with the story problems, and so that you have time to get some help. Um, and we'll see you on the next one.